In this video, we're going to talk about probability with permutations and combinations. So just a reminder about what probability means. Probability is the number of ways something can happen divided by the total number of outcomes. So our first page is going to be a little bit of review of permutations. So if I look at this first example, it says a specific program requires the user to use a 5-digit password. The digits cannot repeat and can be any of the 5 digits. 1, 2, 3, 4, 7, 8, 9. So I have 7 options, and it's going to be a permutation. I'm going to choose 5 of them because order does matter. And that'll get me 2,520. So that's the total number of outcomes I could have of making a 5-digit password where the digits cannot repeat out of 1, 2, 3, 4, 7, 8, 9. Okay, so now this is part B, is I'm going to find the probability. So probability, remember, is number of outcomes over the total. So I already have the total. My total is part A. So really, in part B, I'm going to find the top number, and then I'm going to divide to find the probability. So it says, what's the probability that the second and the third digit are odd with the other digits remaining any of the other remaining numbers? So I have 1, 2, 3, 4, 5 digits. Now they want my second and third digit, so this guy and this guy, to be odd. So if I look at my numbers, I have 1, 2, 3, 4 odd numbers. So that means I have 4 options for this guy and 3 options for this guy. Now, to begin with, I'm going to have 7 options to start off with for that first one, because he can be even or odd. Then I'm going to have 4 options and 3 options, because those have to be odd. But let's say they weren't odd, then it would be 6, then it would be 5, which means I have 4 numbers left to choose for this spot and 3 numbers left to choose for this spot. And so that would give me 1,008 options. So now, to answer the question, I want to do the probability. My probability is always the number of possible over the total number of possible. And so this would be 0.4 or 40%. And so that would be my probability that the second and third digits were odd. So let's do something similar in example 2. In example 2, it says a group of 6 students, 4 boys, 2 girls, are lined up at the door. How many different ways could they line up? Well, there's 6 possibilities, and I'm picking 6 of them. So remember, that's the same as 6 factorial, which would be 720. Okay, so now here comes the probability part. So the first 2 in the line are girls. So I want the probability that the first 2 in the line are girls. So I could think of this kind of like I did the first one, where I can do my spaces. So I have 6 spots in line. The first 2 are girls, so I have 2 options and then 1 option. And then I have 4 options for boys, 3 options for boys, 2, and then 1. And that would give me 48. Or I could think about it as the first part of the line is 2 girls, and I'm picking 2 girls. And then I have 4 boys, and I'm picking 4 boys. And that's going to be my order. And that will also give me 48. So either way you want to think about it is fine. But now when I'm going to calculate the probability, I need to take my 48 as my numerator and my 720 from part A. And I'm going to get 0.067, which would be 6.7% probability that that's what happened. All right, I'd like you to try 1 and 2 under this group work section. Those are review from yesterday. So pause the video now, try those 2, and then play the video and check your answers. All right, so if you look at number 1 under the group work section, tomorrow has 8 total letters, so it's going to be 8 factorial over 3 factorial, 2 factorial. 3 factorial comes from the fact there's 3 O's, and 2 factorial comes from the fact there's 2 R's. If I type that in my calculator, I'll get 3,360. Okay, for section 2, A, B, C, D, we were supposed to determine if it was a combination or a permutation. So A, when you're selecting 2 marbles, that's a combination, because it doesn't matter what order I pick, I'm just selecting 2. B is a permutation, because again, it's about placement. So the placement of the top 10 finishers of the spelling bee. So that's about 1 through 10, so that's order matters. So that's why that's a permutation. C is a combination, because I'm just picking 4 of the candles out of a box of 10. I should say of 10, sorry about that. D, choosing 2 dogs from a litter of 2 males and 2 females. Again, this one got more specific, but again, I'm just choosing 2. It doesn't matter who I pick first or second, so it's a combination. All right, so let's continue using combinations and permutations and use it in terms of our probability. So we look at example 3. Example 3 is actually a lot like example 1. So go ahead and pause the video now, see if we can get example 3, and then play the video when you're ready. All right, so example 3 is a permutation because we're talking about the order of a password. So there's 6 numbers you can choose from, and I'm picking 4 of them, so 6P4. So I have 360 total possible outcomes. Now, the probability that the first and third digit are odd. So if I was just finding the total number of outcomes, it'd be 6, 5, 4, 3, as I wrote kind of small below it. But since my first and third need to be odd, well, 3 of my numbers are odd, so that I have 3 choices for that first spot. And then once I put an odd number in that spot, I only have 2 options left. So it'd be 2. But then for that middle spot, once I've already picked one for the first spot, I still have 5 options, and then 3 more options for that last spot. So I have a total of 90 options. So my probability would be 90 over 360, or 25%. All right, go ahead and try example 4. Now remember, be careful to think about if it's a permutation or a combination. Remember, permutations order matters. When you're ready, play the video and see how you did for example 4. All right, number 4 is a little bit more difficult. So in number 4, it's going to be a combination. And that's because we're choosing a committee of 4 members out of 10. It doesn't matter who's picked first or second or third or fourth. I'm picking 4 out of 10, or choosing 4 out of 10. So it's 10 choose 4, which means I have 210 total combinations of people that I could be on my committee. Now part B wants me to figure out the probability if 2 members on the committee were men. So now, this is where it becomes a little tricky because there's part of the problem they didn't tell you. So if I have 4 men, I'm choosing 2 of them, but then the other half of the committee, I have 6 women and I'm choosing 2 of them. That makes a total of 4 for the committee. So even though they're telling me only 2 members are men, I have to remember the part they're not telling me is that 2 are going to be women. So then I multiply 4 choose 2 and 6 choose 2, and I'm going to get 90. So then I turn that into a probability. 90 over 210 is 0.429, or 42.9%. All right, using the same model, go ahead and try example 5. It's very similar to example 4. So pause the video, give example 5 a try, play the video when you're ready. Okay, so in example 5, it says there's 6 positions available at a new restaurant, 8 men and 9 women applied. So that's a total of 17 people. So if I have 17 people, I'm choosing 6 of them. So again, it doesn't matter what order I'm choosing, so that's why it's a combination. Then what's the probability 4 women are hired? So remember, I want 6 positions. So if 4 women are hired, that means 2 men are also hired. So if I have 9 women and I'm choosing 4 times 8 men and I'm choosing 2, that's 3,528 possible ways. So when I do the probability, I'm going to do the 3,528 divided by the 12,376, And so the probability that that would happen would be 28.5%.